Good morning, students. Today we are looking at the first chapter, that is rational numbers. Before that, we will start with some of the other type of numbers. First is the natural numbers. Natural numbers start with 1. For example, try this equation. X plus 2 is equal to 13, where x is given as 11. So x is a part of a natural number. Now we took another equation, x plus 5 is equal to 0. Here x is equal to 0. So x is not a part of natural number. For that we have another set of numbers called whole numbers. Whole numbers start at 0 and continue till infinity. Now try this equation, x plus 18 is equal to 5. So x is equal to minus 30. X is less than 1 and x is also less than 0. So x is less than 1, so it is not a natural number. X is less than 0, so it is not a whole number. For such type of numbers, we have another set which is called integers. In case of integers, x start from an infinite value, continues for minus 1, minus 2 and to 0, and then 1, 2, 3 up to infinity. So we can say that x is an integer. Now we have seen natural numbers, whole numbers and integers. Now we have to see numbers which are in between 0 and 1, 2 and 3 and minus 1 and minus 2. These numbers are not integers, whole numbers or natural numbers. For example, you take of 2x is equal to 3. Here x is equal to 3 by 2. It is not a natural number, whole number or an integer. Such numbers are called rational numbers. Take another example. 5x plus 7 is equal to 0. Here x is equal to minus 7 by 5. This x is also a rational number. Now we will look at different properties of the numbers. First, we will look at the closure properties. Closure property means that if you are doing any operation with one type of numbers, the answer should be also that same type of number. For example, we are taking whole numbers addition. Here 5 and 1 we are adding to get 6, which is a whole number. Another is 2 and 7 we are adding to get 9, which is a whole number. So as far as addition is concerned, for whole numbers it is satisfied. Now we'll take the example of subtraction. Take the second example. 17 is a whole number, 29 is a whole number, but minus 12 is not a whole number. So for subtraction, closure property is not satisfied. Now we are going for multiplication. Multiplication is also called repeated addition. Take two whole numbers, 6 and 10. Answer is 60, which is a whole number. Take another example, 9 and 11, which is whole numbers, 99, which is another whole number. So for multiplication, closure property is satisfied. Now we can go now to the division part. Division is also called repeated subtraction. Take the second example. 5 we are dividing it by 8. 5 when is divided by 8, it is not a whole number. So in this case, closure property is not satisfied. So in case of whole numbers, addition and multiplication, closure property is satisfied. Now we will look at the integers. First is the addition. Take minus 6 plus 5 gives minus 1. It is an integer, so it is satisfied. Another is 7 plus minus 3, which is 4. This is also an integer, so closure property is satisfied. Now we will go to the subtraction part. 11 minus 8 is equal to 3. This is an integer, so it is satisfied. Another is minus 19 minus 33. That is a integer, so we can say that Integers are closed under subtraction. We are now looking at multiplication. Take the example 5 into 8. It gives an answer of 40, which is an integer. Now take another example minus 5 into 8, which is minus 40 gives an integer. So integers are closed under multiplication. Now we look at division. Division, we are taking the second example. 13 divided by 2. 13 divided by 2 is not an integer. So integers are not closed under division. We can say that for integers, addition, subtraction and multiplication are closed. But for division, closure property is not satisfied. Now we can look at the rational numbers. Rational numbers are represented by P and Q, where Q is not is equal to 0. Now first we are looking at the addition part. Consider the equation 3 by 8 by minus 7 by 5. That is equal to 3 by 8 plus minus 5 by 7. The common factor is 56 and here we have 21 plus minus 40. The answer is minus 19 by 56, which is a rational number. Take the another example 8 by 11 plus 7 by 13. Their common factor is 143. Here we can see 104 plus 77, which will give the answer as 183 by 143, which is a rational number. So in previous case, addition was satisfied. Now we look at the subtraction. Minus 7 by 5 minus 2 by 3. The common factor is 21. It is minus 40 minus 15. The answer is minus 21 by 29 by 21, which is a rational number. Now take another example 7 by 12 minus 9 by 16. It gives 48 as the common factor. So for 28 by 48 minus 27 by 48 gives 1 by 48. That is also a rational number. So in rational numbers are closed under subtraction. Now we see the multiplication. Minus 2 by 3 into 4 by 5 gives the answer as minus 8 by 15, which is also a rational number. Minus 4 by 5 into minus 6 by 11 gives 24 by 55, which is also a rational number. So rational numbers are closed under multiplication. Now we see the division part. Here we say 2 by 7 divided by 5 by 3. The answer is 6 by 35, which is a rational number. Take the second example. Minus 3 by 8 divided by minus 2 by 9. Answer is 27 by 16, which is also a rational number. But when we divide, take the third example 11 divided by 0, which is undefined. So we can say that rational numbers is not closed under division. That is because 0 is a rational number, but we cannot divide anything by 0 which is undefined. So as far as rational numbers are concerned, addition, subtraction, multiplication are closed, but division is not closed. We are looking at associative property. For associative property of three constants a, b and c, for example, for addition, a plus b in bracket plus c in LHS should be equal to a plus b plus c in bracket. Now we are looking at the whole numbers. LHS should be equal to RHS. First is addition. 19 plus 14 plus 16 in bracket should be equal to 19 plus 14 plus 16. Now, first bracket is opened, so 19 plus 30, another 19 plus 4 gives 33 plus 16. So answer is 49 is equal to 49. So LHS is equal to RHS. So addition is associative. We are looking at subtraction. 19 minus 14 minus 16 and 19 minus 14 minus 16 in bracket. 19 minus 16 is 5, minus 16 is coming down. 19 minus 14 minus 16 minus of minus 2. So 19 plus 2. Here 5 minus 16 is minus 11 and here 19 plus 2 is 21. So LHS is not is equal to RHS, so subtraction is not associative. Now we look at multiplication. 5 into 6 into 3 should be equal to 5 into 6 into 6 into 3. 5 into 6 is 30 and here 6 into 3 is 18, so it is 30 into 3 and 5 into 18 give the answer as 90 each. So multiplication is associative. Going to the division, in LHS it is 19 divided by 3 in first bracket divided by 2, it should be equal to 19 divided by 3 divided by 2. So it will become as 19 divided by 6 in LHS and 38 divided by 3 in RHS. So division is not associative. So as far as whole numbers are concerned, addition and multiplication is associative, subtraction and division are not associative. Now we go to the integers. Addition, we check for associative property. 18 plus minus 7 in bracket plus minus 23 in LHS. 18 plus minus 7 plus minus 23 in RHS. It will become as 11 minus 23 in LHS and 18 minus 30 in RHS, which gives minus 12 and minus 12 as answer. So addition property is having associative property. Now we will check associative property for subtraction. Take this example. Minus 55 minus 17 in first bracket minus 33 in LHS and minus 17 minus 33 in the second bracket in RHS. Minus 55 plus 17 will become minus 38 minus 33 in LHS, and here minus 17 minus 33 will become 50 and minus 50 will become plus 50. So 55 plus minus 55 plus 50 in RHS. So in LHS it will become minus 17, in RHS it is 5. So associative property is not satisfied. See the multiplication for associative property. 5 into minus 7 in first bracket into minus 8 is equal to 5 into minus 7 into 8. So LHS should be is equal to RHS. First we take down the brackets, it will give minus 35 into minus 8. Here it will become 5 into minus 56 in plus 56 in RHS. Minus 35 minus 8 will give 280 in LHS, and 5 into 56 will give 280 in RHS. So LHS is equal to RHS. So multiplication is associative. Now we look at the division. Minus 10 divided by 2 but divided by minus 5 should be is equal to 10 divided by 2 divided by minus 5. LHS should be equal to RHS. Here first we to take the brackets down. LHS we can give minus 5 divided by minus 5. In RHS we can say minus 10 divided by 2 by 5. So when we take down the brackets, we get 1 as answer in LHS, and in RHS the answer is 25. So we can say that division is not associative. For integers, addition, subtraction, addition is associative, multiplication is associative, but subtraction and division are not associative. Now we are looking at rational numbers. Rational numbers are represented by p by q, where p is an integer, q is an integer, but q should be not equal to 0. First we are looking at the addition. Minus 2 by 3 plus 3 by 5 plus minus 5 by 6 should be is equal to minus 2 by 3 plus 3 by 5 plus minus 5 by 6. LHS should be is equal to RHS. First we look at the LHS part. LHS, the common factor is 30. So 18 minus 25 should be, and we will get as 2 by 3 minus 30 by 7. So when we take the common factor is again 30. So it will become as a minus 27 by 30 in the LHS part. Now we are looking at the RHS part. First we will take the bracket down. So 3 and 5 common factor is 15. It will become minus 10 plus 9. So the answer will be equal to minus 1 by 15 plus minus 5 by 6. Common factor is again 30. Then it will become minus 2 minus 25 by 30. The answer is minus 27 by 30. So we can say that for rational numbers, addition property is satisfied. Now we go to subtraction. Minus 2 minus 3 minus 4 minus 5 minus 1 by 2 in the bracket. In the bracket we have minus 2 by 3 minus minus 4 by 5, close the bracket, minus 1 by 2. We'll now look at the LHS part. The common factor between minus 4 by 5 and minus 1 by 2 is 10. When we take the common factor as 10, you will get to minus 8 minus 5, which is equal to minus 13 by 10. So minus 2 by 3 minus 13 by 10 is equal to minus 2 by 3 plus 13 by 10. The common factor is again 30. So it will become minus 20 plus 39 by, it will be, our last answer will be 9 by 30. Now we are talking the RHS part. So it will be minus 2 by 3 minus 4 by 5 in bracket. So when we open the bracket, it will become minus 10 by 15 plus 12 by 15. It will be equal to minus 2 by 15 minus 1 by 2. So it will become 2 by 15 minus 1 by 2. 30 is the common factor. It will become 4 minus 15 by 13. Answer is minus 11 by 30. So LHS is not is equal to RHS. So subtraction is not associative. Now we look at the associative property of multiplication. Take this example. Minus 7 by 3 into 5 by 4 into 2 by 9 should be equal to minus 7 by 3 into 5 by 4 into 2 by 9. First we take the LHS part. Opening the bracket, it will give 5 by 4 into 2 by 9. It will come as 5 by 18 into minus 7 by 3. So the answer will be minus 7 into 5, that is 35, and 3 into 18, that is 54. Answer is minus 35 by 54 in the LHS. In RHS, it will come minus 7 into 5 by 3 into 4. So it will become minus 35 by 12 into 2 by 9. 2 and 12 will get cancelled. It will get 6. And the answer will be minus 35 by 54. So LHS is equal to RHS. So in multiplication, the isosceles property is satisfied. Now we'll look at the division part. Take this example. 1 divided by minus 1 by 3 divided by 2 by 5 in LHS, and 1 divided by minus 1 by 3 divided by 2 by 5 in RHS. First we take the LHS part. 1 divided by minus 1 by 3 into 5 by 2 will be equal to 1 divided by 1 by 2 divided by minus 5 by 6. So it will become 1 by 2 into minus 6 by 5. The answer is minus 6 by 10 in LHS. Now we will see the RHS part. 1 divided by minus 1 by 3 in the bracket. First we will open the bracket, will give 1 by 2 into minus 3. The answer will be minus 3 divided by 2 divided by 2 by 5. So it will become as minus 3 into 5 by 2. The answer is minus 15 by 4. Here LHS is not equal to RHS. So as far as division is concerned, associative property is not satisfied. We are here now to explore the rule of 0 in case of addition. When we add 2 plus 0, the answer is 2. And when we add minus 6 plus 0, the answer is minus 6. Here 2 is a whole number. The answer will give us 2, which is also a whole number. Minus 6 is an integer. The answer also will give minus 6, which is an integer. Here we take a minus 11 plus 8 plus 0. Here the answer is minus 11 by 8, which is a rational number. So as far as addition is concerned, what any number plus 0 will give the same number. If it is a whole number, it will give the same whole number, and if it is an integer, it will give the same integer, and if it is a rational number, it will give the rational number. Multiplication rule of 1. 5 into 1 is equal to 5, which is a whole number. Minus 7 into 1 is minus 7, which is an integer. Minus 2 by 3 into 1 gives minus 2 by 3 an answer, which is a rational number. Rule of 0 is for addition. Any number plus 0 will give the same number, whole number, integer or rational number. Rule of 1 is for multiplication. A number multiplied by 1 will give the same number even it is whole number, integer or rational number. Please keep it in mind.